Okay, I promised a solution to this problem. This is one of the questions from the MIT Integration between 2025 registration season. So we are going to look at how to go about this solution. Now this is combination of trigonometric function and the hyperbolic functions. So we recall that from the hyperbolic function, we know that sin x can be written as exponential harmonic of x minus e to the power of minus x divided by 2. Yes, we have this. Reason being that sine here is an odd function. So we have this. We can simply, choose this in here and obtain a solution for this. On substitution, this can be summarized as half in the bracket of exponential x minus exponential of x. So on substitution, the integral becomes sine x multiplied by half in the bracket of e to the power of x minus e to the power of minus x dx. So let's bring this to this side. So what we are going to have here is e to the power of x sine of x minus e to the power of minus x sine of x. So what we are having here is more or less, we can call this I1, call this I2. Our aim now is to evaluate integral I1 and integral I2. So let's see. Integral I1, which we have e to the power of x sine of x dx as our main equation. This integration by part, call this u, call this dv. So if we do this, since u is e to the power of x and it implies that du maintains itself, and dv equals to sine x dx, v equals to minus cos of x, so that our I1 becomes uv, that is the formula by part, v du, which will be uv minus e to the power of x cos of x minus integral of v here is minus cos of x. Okay, no need putting this in bracket. Multiplied by du, which is still e to the power of x dx. So this will resolve us to minus e to the power of x cos x minus x plus, so we have integral of exponential x cos of x dx. We'll still do this by parts. We should have e to the power of x cos of x plus, open a bracket, uv. We have exponential x sine of x minus whatsoever that will be left is just what we have as I, to still give us the initial integral we began from. So that is all we're going to have from there. So this I1 becomes e to the power of x cos x plus e to the power of x sine x minus I1. So by the time we add I1 to this way, what we're going to have here is 2I1, which is rearrange this and factor out exponential x. What we're going to have here is sine x minus cos of x. And what divide both sides by 2. So our integral I1 will be half of e to the power of x over 2 in the bracket of sine x minus cos of x. So we have this. We'll come back again. We're not done. We'll come back to this. But what we can easily do here is for we to now use the formula. Okay, if we don't want to use the formula, no problem. We can still go back by solving it gradually again. It's for the sake of explanation, for we to understand what we are doing. Now, I2 is integral e to the power minus x sine of x dx. The same way we have done, if u is e to the power of minus x, du will be minus e to the power of minus x dx. If dv is equals to sine x, just the way we have it, v will be equals to minus cos of x. So our I2 will be uv minus x cos of x minus integral u v du, which is minus cos of x times minus exponential minus x dx. So this will actually take a different term from the other because of the negative x at the exponential. So we have this as minus is still minus, so we have the integral exponential minus x cos of x dx. Still do this as integration by parts, which I know we have the knowledge already. So we proceed. We should have e to the power of minus x cos x. We are still going to see another shorter way of doing this problem. Yes, I'm going to show you an alternative. Measure this minus, open a bracket. Right now we do this again. We are going to have e to the power of minus x sine of x. Then what we are going to have here is we are having a negative, so this will be a positive I2. Yes. So by the time we expand this bracket, this will give us minus I2. By the time you have I2 to this way, you have integral I2 equals to, okay, the minus sign is common, so we bring out minus x, close the bracket. You have cos of x plus sine of x, so that I2 will now be minus e to the power of minus x over 2, open the bracket, cos of x plus sine of x. So recall that we had the last integral expressed here earlier as half integral of I1 minus I2. So we substitute back into that expression. If we do this, now we recall that our last expression was half integral of e to the power of x sine of x minus e to the power of minus x sine of x. This was when we had, before we named this first integral as I1, the second integral as I2. So our final result will be, what do we have for I1? I1 is minus e x over 2, open a bracket, sine of x minus cos of x. Then minus, what do we have for I2? Minus become plus. So what we have there is exponential minus x over 2, open a bracket, cos of x plus sine of x. So close this overall bracket and multiply both sides by half. So what we are supposed to have is now, this comes first now because of the positivity. Okay. Let's see. What do we have here? Okay, there was no minus here. Thank you. There was no minus here. So multiply out. We have e to the power of x over 4. Open a bracket. Sine of x minus 2 sine of x plus e to the power of minus x over 4. Open a bracket. Cos of x plus sine of x plus constant. So this is our solution. Thank you, and we await the alternative solution then.